Hello everyone. So let's start another new chapter, that is AutoCAD 3D. This is the completely new chapter where we will be understanding lots of 3D tools, how to change your AutoCAD 2D mode to 3D mode, and we will be watching how to create complicated 3D models in this AutoCAD 3D. And also we will try to differentiate between AutoCAD 3D and other 3D softwares, CAD softwares like SolidWorks, Creo and all. So let's get started. Whenever we open AutoCAD 3D, AutoCAD, not AutoCAD 3D, AutoCAD, we will see that these options will be there. By default, the workspace will be drafting and annotations. We have some other as well, 3D basics, 3D modeling. Okay, 3D basics and 3D modeling. So let me tell you one thing. First, change your workspace. We have 3D basics workspace. In the 3D basics, see the tools are changed now. Okay, the tools are changed. Now go to 3D modeling again. If you go to 3D modeling again, you will see that the tools are changed and there are more advanced tools are present to use in 3D. But the drawing area which I can see is 2D. Okay, so you can see as I change, it is drafting and annotation workspace where 2D tools are available. Okay, these are 3D basics. 3D basics, only basics tools are available, and this is the 3D modeling. Here more advanced 3D tools are available, but the drawing area is not up to the mark. So to switch into 3D, what we have to do, either you can go there. Can you see this? Yes, this home button. If you left click here, you will see that the screen will become isometric. This is your x-axis, this is your y-axis, and this is your z-axis. Now you will be able to see the z-axis as well, because now we have entered into the 3D. You can scroll up or scroll down to see the A4 size grid, which I always set using limit. Okay, this is one of the way for switching 2D to 3D. Okay, now can you see here unsaved view? In the unsaved view, you can see that there are different options are there. Top, as of now, you are seeing the top. This is the top view, you can say top view. Okay, go to bottom view. So this will be the bottom view. Okay, see the x and y axis, how this has changed. See, So this is the top view. You can click here as well. See this one for switching the views. You can do undo, Control Z, so that you can come to your original view. Okay. You can press this arrows as well, means left click onto this arrow so that you can switch the views. Okay. Now you can see here SW isometric. SW isometric means, see, this is the SW. This is the south. This is the west. This is the north. This is the east. Okay. So SW means southwest. Means if I press here southwest, it will show the southwest direction. Means whatever you will see, it will show the southwest. From the southwest direction, this particular grid will look like this. Yes. Or you can go to southeast like this, it will show like this. So this is the x-axis, this is the y-axis, and this is the z-axis. I have already told you that this is your UCS. Okay. Now just remember one thing, whatever 2D drawings we are going to draw, we will draw in the XY plane only. Most of the drawings we will draw in the XY plane, and that 2D will be converted into 3D in the Z direction. So this is the 3D modeling workspace. I hope this is very much clear to you. Now, can you see here? This is the home. We have solid. See, there are different options. Solid, then surface, then mesh, etc. Then we have parametric. Okay, so first we will start off with this particular. These are some of the basic geometric tools. Okay, so now we are into the AutoCAD 3D space. Okay, now can you see the first object? The first option is box. Okay, or you can press BOX, box. Okay, enter. Box, either you can access from command line or from here as well. Okay, now the first corner, actually you have to make rectangle first. The other corner, this is the other corner. Now it will ask height. This is the positive Z direction, this is the negative Z direction. This is the positive Z direction, this is the negative Z direction. So positive Z direction is, let me give 250. So this is the box which I have created. Now you can see that although I have drawn it in 3D, but it is looking like sketch is there. So what you should do, can you see here 2D frame, 2D wireframe? Go there, and we have different visual styles. These are visual style. Go to shaded with edges. Shaded with edges. So it will look something like this. So this is the 3D box. Okay, this is the 3D box. Let me erase this. See, once you come here, shaded with edges, see your UCS, how it has changed. X, Y, and Z. Okay, now let me erase this. See, I have selected this one. So you can see that we have one red 3D coordinate system, means 3D axis will also showing on the object. Okay, it has some use. I will explain what's that. Delete it. Okay, now go to box again. Now go to center. This is the box center. Now it is asking to specify the center. So left click. So now it is the center. Now it is making with the help of center. Okay. Now left click here and you can see it is asking height. Suppose if I give height of 250. Now I know how to rotate. How? Press and hold the shift and press and hold the middle button of the mouse and move your mouse. You will see that the screen will rotate. See, half of the portion is above the grid and half of the portion is below the grid because we have chosen center after the box. Okay. Yes. Now suppose you want your normal view, go to here SE isometric. Okay, SE isometric, that is southeast isometric. Go to command distance DI, enter. You can measure. See how much it is from here to here. From here to here. See how much it is showing? 250 because I gave a height of 250. Okay. Now go to SE isometric again. Erase this. Go to box again. Okay. First corner. Now, once I select the first corner, now we have two options, cube and length. So go to cube. See, now cube length. Okay. Cube length it is asking. Let us give cube length as 50. Cube has all the three dimensions as equal, right? So cube length as 50 and it is done. Go again to the box. First corner, then go to cube. Okay, press F8. If you press F8, now ortho is on. See, the ortho is on, right? The ortho is on. If the ortho is on, then the box position will be fixed. Okay, now give the length, means the box position will be fixed along x and y axis. Yes, give 70. So you will get a cube of 70 length. Okay, delete it. Now go to box again. First corner. Now we have length. Let us give length as 100 now. Okay. Now it is asking width, means along this direction. Okay. Let me give it as 150. Okay. Now it is asking height. So height you can directly mention or we have option 2 point. Okay. So it is asking 2 point. The first point and the second point. The first point is 1 from where you want to draw the box. Okay. See, this is the box which I have drawn using 2 points. Okay, let me draw a line here. See, the ortho is on as of now. Okay, see, the ortho is off. Now ortho is on. This is along y-axis. This is along x-axis. This is along z-axis. So I am drawing a line. See, again z-axis. Now this is the line along x-axis. This is a line along negative x-axis. This is a line along positive y-axis. Okay, this is a line along positive z-axis. Enter. So you can see this line is a 3D line because I have drawn this line is along z-axis, this line is along y-axis, and this line is along again z-axis. Okay, so again maintain the view. How? press here, southeast. If you press this corner right here, you will get southeast. Okay, southeast isometric. Now go to box, first corner. Okay, go to length. Let us give length as 50, width as 100, and height. Okay, go to 2p. Let the first point be this point and the second point be this point. So you can see the height of the box is equal to the length of this line. So that's the beauty of 2 point inside that box. So this line I have drawn using line command. Okay, I will explain in depth that line command, what is the use, what are the application of it. Don't worry. So the box command is done and dusted. Now let's move on to the next command, that is cylinder. Obviously, you know, cylinder is nothing but a circle is converted into a cylinder, or you can say the cross section of the cylinder is a circle. So you will see all the, okay, all the options here of circle. See 2p, 3p, 2p, ttr, elliptical. So let me give center point. So give center point. Okay, now it is asking base radius of the cylinder. Let me give 100, enter. Okay, specify height. Okay, height. Let me give height as 120. So see, it is a cylinder. You can easily observe that it's a cylinder. I hope this is very much clear. Go to cylinder again. Okay, 3 point. First point, second point. See, first point. Go to 3p. Better draw some 3 points there. Okay. I will choose the end point of this line as 3 point, because whenever I was choosing from that 3 point, it was not happening perfectly. You will get confused. So go to 3 point. This is the first point. This is the second point. This is the third point. Okay, 3 point and height you have to mention. Again, there is an option called 2 point for specifying the height. You already know what 2 point is, as I have explained in the box. Now we have axis endpoint. Okay, axis endpoint. So that's the axis endpoint. Just click randomly, you will get the that same option, axis endpoint. Okay, let me explain one more thing. Go to there, center point, base radius, height. You can see here one thing. When I am going into the cylinder, specify center point. This is the center point. This is the base radius. This is the height. Now you can see this cylinder is not getting rotated. Is it? No. But if I model this cylinder using 3p command, observe one thing. Now the circle is drawn using 3p and this is the cylinder along z-axis. But if you go to axis endpoint, now you can mention your axis here as well. You can mention your axis in this direction as well. You can mention your axis in this direction as well. In which direction you want this cylinder? Along this direction, or along this direction, that is z direction, or along y direction, or along x direction. This is the cylinder axis is along x-axis. The cylinder axis along y-axis in this position, and this is the position of z-axis. Means cylinder axis is along the z-axis. So that's the beauty of this axis endpoint. Suppose I want in this direction, So switch it here and left click. Or you can directly give the height. Yes, see here. Now center point, base radius. Now go to axis end point again. You can switch your direction. Suppose you want the cylinder axis to be along the y-axis. So move there and give the length. Suppose you want a height of 350. So give it the height of the cylinder, that is the length of the cylinder is 350. So this is how it is. This will be really useful. Now next command is cone. You already know what is cone here. So we have some more options in cylinder as well. 2P, TTR, elliptical. You can also draw an elliptical cylinder. Okay, this thing I am assuming that you already know this thing. Okay, suppose you want to draw a elliptical cylinder. So first draw a major axis. Let's say the major axis length is 200. Okay, and the major axis direction is along x. Let's say draw a minor axis and the minor axis length, let it be 100. And the minor axis direction is along y direction. Now move with this particular line from here to here. Okay, exactly. Now go to cylinder, elliptical, first endpoint, second endpoint, and there's the minor radius. Okay, now height. You can specify the height using 2 point or axis endpoint. If you go to axis endpoint, then you can switch your direction like this. So this is the elliptical cylinder. I hope you got my point. Now we have some more options. 2P. 2P means 2 points. Those 2 points will be the diametrical points. Okay. Yes, 2 point and the height. The third one is TTR. This is the tangent. This is the tangent and specify radius 100. Okay. So tangent to this line, tangent to this line, radius and height. So this is the cylinder which is tangent to these two lines. Now we have cone. Go to cone, center point of base. Okay, so center point, base radius you have to mention. Let me give 150. Okay, now again we have different options. 2 point, axis endpoint. Just go to axis endpoint. You can switch the direction. Suppose if you want to. Suppose you want the cone along this direction, means the axis of the cone is along the y direction. Just give 700 as height. Just type 700, enter. You will see that a cone has been made whose direction, the axis direction of the cone is along y direction. Go to cone again. Okay. Center point of base. So this is the center point. Okay, give radius. Now 2 point is already known to us. Axis endpoint is already known to us. Now this is very interesting. Top radius. I have mentioned the base radius, center and base radius. Now top radius. If the top radius is, let us say, 10. Now you can see here, this is a truncated cone. Okay, truncated cone having two radius. top radius and the base radius. I hope this is clear. Now go to cone again. Okay, now all the options you already know: 3P, 2P, TTR, elliptical. Elliptical cone you can also draw. Okay, first endpoint, second endpoint, then this. See here, you can easily draw. And also you can give top radius. Go to top radius. Let us give top radius as 20. Yes, this is how it will be. Means this particular section will be smaller than this. Okay, cone, go to elliptical, first axis, second axis, this one minor radius. See, as of now the top radius is 0. Go to top radius, and suppose if I give 120, suppose. Now you can see here, if I give 120, it will be bigger than this, bigger than the bottom. Actually 120 is what? 120 is nothing but your, you can say, percentage. Means the bottom cross section and the top cross section, both the cross section are having different dimensions. How much is bigger? How much the top cross section is bigger than the bottom cross section? It is 20% bigger, because I have given 120. Top radius as 120, right? See, go to cone, go to elliptical, this one, this end, this is the major axis. Now this is the minor radius. Okay, now go to top radius. Suppose if I give top radius as 50, means it will be 50 percentage. It will be 50 percentage. This cross section, the top cross section is 50 percentage of the bottom. I hope this is clear. So this is the truncated elliptical cone. Okay, exactly. Now we have another option called sphere. Sphere you already know. Suppose this is the center point, mention radius. Suppose the radius is 50. So this is the sphere. You can see. Okay, very simple. Go to sphere again. Okay, 3 point, first point, second point, and third point. See, the sphere will be drawn like this. Half is above the grid and half is below the grid. Go to sphere again. Okay, TTR you already know. Tangent, tangent. Let us say radius is 120. So tangent, tangent, radius, and this is the sphere. Means radius is around 120. I gave, right? Yes, 120 is the radius and tangent to this particular line and this particular line. You might be having doubt, sir, how to bring this particular sphere above the grid. You have to move it. You have to move it. We have 3D move. I will explain what is that 3D move. How to move this sphere. Okay. Yes. Now go to pyramid. Yes, sphere is done. Okay. Now go to pyramid. So in the pyramid, it is quite similar to your polygon. You have to mention the base. Okay. See, you have to mention the base. So center point of the base. Let me give center point of the base as this one. Okay. Yes. Now we have option inscribed, or it is asking base radius. Okay, let me give base radius as 150. Okay, base radius as 150, and this is it. This is the pyramid having 4 sides. Go to pyramid again. You can mention the edges. Rather, go to pyramid, sides. First, number of sides, I want 6. Suppose I want number of sides as 6. Now edge. Suppose you want to mention the edge. So first endpoint of the edge, second endpoint of the edge. Now you can easily draw. Again, we have options. You can specify the height, but the axis of the pyramid will be along the z-axis. Suppose you want to change your axis of the pyramid, you have to go to axis endpoint and you can change your orientation, or you can change your axis of the pyramid like this. See, it is along z-axis. Now the pyramid axis is along the y-axis. Now the pyramid axis is along the x-axis. So this is how it is done. I hope this is very much clear. Okay, left click, you will get done. Go to pyramid again. Okay, let me set this time 3 as the number of sides. Now edges. Okay, this is the first endpoint. This is the second endpoint. So this is the pyramid. Okay, you can give 2 points. Let us say this is the first point and this is the second point. Suppose you want the second point the second point is above 250. 250 above the first point. Second point is 250 above the first point. So 250, enter. So this is how it will look, the pyramid. Okay. Yes. Go to pyramid again. Now edge, edge. Suppose you want to give the length of the edge of the what can I say, pyramid. Okay, then you have to go to edge like this. See, first endpoint and second endpoint of the edge like this. Okay, now one more option, specify center point. Suppose this is the center point. Actually center point, it is the center of the circle. Okay, now suppose the base radius is, let us say, 100. Now we have options, top radius. Okay, suppose if I give top radius as 20, it will be 20%. The cross section at the top will be 20% of the bottom. Go to pyramid. Let us say this time I will take number of side as 6. Let's say this is the center point here. See, this is the hexagon. Suppose you want inscribed, so go to inscribed. So this will be the inscribed in circle, means the hexagon is inside the circle. I have already explained what is inscribed and circumscribed. In AutoCAD 2D, I had already explained in the polygon chapter. In the polygon chapter, I had already explained this. Okay, so I am not explaining it again. Inscribed and circumscribed. Suppose you want to revise, let me do it again. See, there are two things, circumscribed and inscribed. Okay, circumscribed about circle and inscribed in circle. This is the inscribed in circle. This is the hexagon which is inscribed in circle, means inside the circle. And this is the circumscribed about circle, means it is a hexagon which is outside the circle. It is a hexagon which is outside the circle, that is circumscribed about circle. So actually, what pyramid is doing? It is making a hexagon here which can be inscribed or circumscribed. Okay, so let us give the base radius as 50. Okay, that was inscribed, and now you give height. You can give height either by 2-point method, axis endpoint. Suppose you want to change the axis, you can go to axis endpoint. Top radius, if you give top radius, let me give top radius. See, it is 40 as of now. The bottom radius I chose, I don't remember. Let me give top radius. Let's say top radius is 50. So this is the 50. Okay. Yes. I think bottom radius was also 50. Top radius is also 50. But in this case, top and bottom radius both are same. It is not taking 50% of that. Okay. Listen very carefully. This is the center. Okay. Give base radius as 50. Give base radius as 50 and top radius, let us give it as 70. Not 70, give it as 20. Okay. Yes. Now you can see top. Okay, below one is inscribed in circle. Okay, below hexagon, bottom hexagon is inscribed in circle, and the circle radius was 50, but at the top it's again inscribed in circle hexagon, but the radius is 20, which I just chose. Now let us give height by left clicking, or you can directly write the height here. Okay, suppose you want a height of 200, write 200 and press enter. You will get a 200 height pyramid. I hope this is very much clear.